Hey guys, so today we're going to be working with exponents. I'm sure as you can tell that I've been doing a bunch of these all in a row to try to get them up as soon as possible because I'm wearing the same shirt. Everything looks exactly the same, so let's get going again. All right, next we have powers and exponents and whatnot. So most of you should be familiar with it, but for those of you who aren't, we're just going to do, again, a super quick rundown, and then we'll just kind of do some practice problems with that so that way you guys are ready for the Khan Academy stuff. So first off, main idea, multiplication is just multiple addition. When you think multiplication, it's multiple addition. So if I have something like 3 plus 3 plus 3, this becomes 3 times by 3 because we're saying I have 3 of these threes, 1, 2, 3. And that's kind of what's going on when we're doing multiplication. So I have 3 plus 3 plus 3 plus 3 plus 3. That's 1, 2, 3, 4, 5. I have 5 of these threes. That's kind of how multiplication works. They're telling us how many times we are adding the same number. Now, when we're doing exponents, it's basically the same thing, but instead of telling us how many times we add something, we're saying how many times we multiplied that number. So if I have 3 times 3 times 3 times 3, that says I'm multiplying 3 4 times. I'm multiplying the same number 4 times, and this is 3 raised to the 4th. That's what this little number up here is. That's called an exponent. It's also called a power. They're kind of interchangeable at this point, but we're saying, all right, I'm taking 3 and I'm multiplying it by itself 4 times. So if I were to say something like 2 to the 5, that means I'm taking this number here and I'm multiplying it to itself 5 times. 1, 2, 3, 4, 5. That's what 2 to the 5 means. It says I'm taking 2 and I'm multiplying it by itself 5 times. This number down here is called your base. And this number up here is called your exponent. All right, so that's kind of what's going on. That's the general idea. Again, it's kind of like how we're doing multiplication, where multiplication says how many times we're adding the same number. Exponents say how many times we're multiplying the same number. So let's move on to our next problem over here really quickly. So now that we're over here, these are some of the notations that we're using. Again, x times x times x times, or x times x times x says we're multiplying x by itself 3 times. So that's how we get this here, x to the third. Again, x is my base, 3 is my exponent. 5 times 5 times 5 is 5 to the third power. 3 times 3 times 3 times 3 is 3 to the fifth power. Again, the bottom number is your base, the top number is how many times you're multiplying by itself. Now, if you guys remember, 3 times 5 is equal to 15. 5 times 3 is also equal to 15. Whoops, that's a 12. 15. So the order doesn't matter. However, when we're doing this, it totally does matter because 5 times 5 is 25 times 5, which is 125. Whereas if we're doing 3 times 3 is 9, times 3 is 27, times 3 is 81, times 3 is 243. And as you can see, these numbers are very different. So that's why we have to be careful. Is it what's your base and what's your exponent? The bottom number, your base, tells me what we're multiplying by itself. The top number tells me how many times we're multiplying it by itself. Now finally, sometimes we mix and match like this. 3 times 3 times 3 says we're getting 3 and we're multiplying it by itself 3 times, but we're also multiplying 2 by itself 2 times. Now I can't combine these because, again, the numerator tells me, or excuse me, the exponent tells me how many times we're multiplying the same number. Now that we have different numbers, the rules change. We cannot combine these. These are just stuck. It's kind of like combining like terms. If your bases are different, you're just stuck. You cannot do anything else. Again, let me say that one more time. If your bases are different, you cannot do anything else. So moving on, let's do a couple more problems. So it says rewrite an exponential notation versus evaluate. So that requires us to know what it means to be an exponential notation versus what it means to evaluate. And if you guys remember, evaluate means do the math. So what's 3 times 3? That's going to be 9. That's the evaluated version because we're saying what's 3 times 3? It's 9. We just do the math. 3 times 3, though, is also 3 to the second power. This over here is exponential notation because we're not trying to do the math, we're just rewriting it and regrouping it so it's a little bit nicer. It's almost like simplifying here. Again, simplifying means kind of do the math, but we're not looking for a number. Evaluate means tell me what the value is, what's the number gonna be. So if we have something like this, 3 times 3, that's gonna be 3 squared times by a squared, because I'm multiplying 3 by itself 2 times, and I'm multiplying a by itself 2 times. However, that's exponential notation. We can actually do the math because we know 3 times 3 is 9. But I still don't know what a is, and because I don't know what a is, we're still going to have to leave it as a squared. Again, this is your evaluation. The left side is your exponential notation. Finally, the last one we have is b times b times b. That's b to the third power times by a to the second power. And again, this is kind of where we stop. Now, when I'm evaluating it, I don't know what either of these are. So I'm just going to have to leave it as a to the second. And that's it. We're totally done. That's basically the major ideas for exponents. It's fairly simple as long as you remember your exponent tells me how many times we're multiplying the same number to itself. The same number is called base. Now there's something I don't have quite on here, but I did want to highlight it. If you have this exponent of 3, an exponent of 3 is called a cube. So this is b cubed or b cube. And second power, exponent of 2, is called a square. And we call this a squared. So this could be written as b to the third power, a to the second power, or we could say b cubed, a squared. Okay, if you call it cubed or third power, it doesn't really matter, but it is helpful to know what squared and cubed are because in the future we'll say things like this is the cube root, or this is difference of cubes or difference of squares, and it might tell you on an ACT or SAT, look for the cube of this number. And that's kind of a vocabulary word that you're going to have to be familiar with. Now, we do have some slightly more difficult problems, things that look a little bit more like this. And what I wanted to do is, again, let's look at this. How do we evaluate and how do we write an exponential notation? When we have these numbers in front of our variables, these are called coefficients. And if you guys remember, coefficients are basically saying, hey, this is a number times a variable, or how many of these variables do we have? So we can rewrite this as 3 times x times 3 times x, because again, our coefficients are just multiplying to the variable. Now, from here, one thing that you can do, if you remember, it's called the communicative property of multiplication. You can move things around in multiplication, so you can rearrange it as 3 times 3 times x, and it's really nicely like problems we've done before. So in exponential notation, this is 3 squared, or 3 to the second power, times by, again, x squared, or x to the second power. This is kind of how we can write it. Now, another way that we can write it, this is a little more tricky, and I'm gonna briefly go over this, is we can also write this as 3x parentheses squared. And the reason we're doing it is we're just grouping it. We're saying, hey, 3x is kind of like a number, and I'm multiplying it by itself, so we'll just call it 3x squared. The reason this is dangerous, though, is if you have 3x times 3x times x, yeah, I do have 3x squared, but at the same time, too, I could also recombine these x's. So we kind of don't like to do this too much, but just know all this is saying is I have 3x times itself. Whenever it's in the parentheses, whatever's on the inside, that's the base. Whether it's x, whether it's 3, whether it's 3x. This is your base. Your exponent tells me how many times we multiply that base by itself. Another thing to be careful of is when we have numbers like this, 3x plus 2x, this is totally fine. This doesn't affect our exponents though, because exponents don't deal with multiplication, or excuse me, they don't deal with addition, they deal with multiplication. This says I have 3 of my x's and I'm adding it to 2 more x's, which in total should give me 5x. That's it. I don't have to deal with the squareds because remember, by definition, multiplication or these coefficients tell us how many of these x's we're adding together. Last one, if I have something like this, I have 3 x's and 2x squareds. They're different variables. Even though they both use x, they're different powers. So even if it's like, oh, they have 3 kids and 2 parents, You cannot say, oh, there's 5 kids, because even if they're in the same family, they're still different. One's a group of kids and one's the parents. They're different generations. So it's kind of like that. So when we're evaluating this is 3x plus 2x squared. I can't do anything with this because there's nothing to combine because my powers are different. So in summary, a couple things is exponents by definition. Remember, in my class, definition is so important because it helps you understand what's going on. Exponents are saying how many times you're multiplying something. An exponent form means use exponents to evaluate, or excuse me, exponential notation or exponential form means use exponents. 3 squared, that's fine. However, evaluate means actually multiply out the numbers. Regroup your numbers so that your similar variables match up together and your numbers match up together. That's like that. 3x times by 3x times by 2x. We can say 3 times 3 times 3 times x times x times x. Oh, excuse me, this should be a 2, not a 3. And if we do that, we can say this is going to be 3 squared times by x times by, or excuse me, 3 squared times by 2. I don't know why I don't want to write that 2 times by x cubed. We could leave it like this over here, or what we could do is we could actually evaluate this, because we know that 3 squared in this case is going to be 9 times 2 times x to the third, and we know 9 times 2 is simply going to be 9 times 2 is 18, x cubed. So this works as well. This is evaluating and this is exponential notation. So again, make sure you guys know the difference. And then finally, adding doesn't change exponents, they only change coefficients, and you cannot add different levels of the same variable. It's like the whole parents and kids thing. They're different generations, you can't do it. Okay, that's the main basics behind exponents. Please make sure you understand the general gist, because it makes life a lot more difficult if you're constantly switching multiplication and exponents. It makes life really difficult. One of the most common things I see is if I see 3x plus 2x, I see so many kids go 5x squared, and that just doesn't work out. So make sure you understand the general idea. We are going to be working with exponents a lot, and if you understand exponents, it makes your next lesson a lot easier. See you then.